So hey, listen, I'm starting the recording and I'll post it to the agenda. I actually won't be here tomorrow. I was not sniped. I'll be in the school, but not here. So Friday, listen, hey, Friday, I'll have Zoom open. Okay. So I'm sorry.
Tell me coughed on me stats a lot.
Bye, everybody. We're like, we'll see you in a week.
You're like, you said that coin, right? And it didn't want to be here. If I did.
That's really, yeah.
I feel bad for Camille because I know she's not happy about that. I mean, Lane and Levi could roll with this if they care less.
We all know it's the imposter, but we can't kill him. We can't vote him off.
I mean, now we can. So like,
Okay, 13. Radius of circles increasing at a rate of, so A equals pi r squared. Radius is increasing, so dr dt. If it's increasing, it's a positive value of 4 centimeters per minute. How do I know it's dr dt? Because the unit is a fraction. Did you catch that? How do I know it's dr dt and not just r? Because the unit is a fraction in terms of radius measurement in centimeters and time measurement in minutes. Find the rates of change of the area. So find dA dt when r equals 8 and r equals 32. That's two different answers. So part A and part B, 8 and 32. Okay, so if I have to find dA dt, I need to take the derivative of this guy, and I get dA dt equals 2 pi r, that's weird, dr dt. It's funny how dimension stuff works with calculus sometimes. So now for A, dA dt is something when we have 2 pi and when r is 8 and dr dt is 4. So what is dA dt? Yes.
So you have like when it's a question like this, can you like you put in the 8 for the radius now?
Sure.
Should you have done that at the beginning, or would that mess everything up?
Here?
Yeah.
Well, then we would have had A equals 64 pi,
Yeah.
which is actually the answer. That's funny. I think the point of the question was to say, to answer that, oh yeah, that'll work. No, part B proves that wrong.
Okay.
But anyway, when you put a number in here, A equals a number. What's the derivative of a number?
0.
So that ruins it. You can find the area by plugging the radius 8 in here, but not the change in area. Now, I have a question. Think about when the radius is 8 and the radius is growing at a rate of 4 centimeters per minute, okay? The area is growing at 64 pi square centimeters per minute, okay? So 64 pi, that's about 180, 192, something like that. It's 192 square centimeters per minute. Do you think when the radius is 32 and it's growing at a rate of 4 centimeters per minute, the area is expanding faster or slower? Faster?
Then what?
Why?
Because it's all like. I don't have big words.
It's bigger because your hands got bigger.
Oh, really? My
Yeah.
hands grew? Now I got big hands?
You widened your hands.
I know you're the one. Riley, you think faster or slower?
The area goes faster because when you expand the radius, there is more distance for the arc to go out. That creates more area.
There's more diameter, and it's growing at the same rate. So it's gaining more area faster.
Because it does.
In my defense, I didn't understand the question.
Okay.
It just does.
You've got this little circle, and it's growing at a rate of 4 centimeters per minute. Okay? When the radius grows at a rate of 4 centimeters per minute, the area is growing also, right? If the radius of a circle gets bigger, the area gets bigger. Well, the area is growing at a rate of about 192 square centimeters per minute. Okay, so you know what area is the amount of space inside a figure, two-dimensional figure. So if we started with the radius of 32, so a big circle, 4 times bigger, if we started there and we still increase the radius at a rate of 4 centimeters per minute, is the area going to grow any faster or slower or the same? Same? Okay, so let's see. We know dAdt already. dAdt equals 2 pi times my new radius is 32 times the drdt of 4. So that's 8 times 32. That's 240, 256 pi. 6 square centimeters per minute. Why?
I can draw.
Because when you have like a circle like this, it has a radius of say 4.
Uh-huh.
And then when it's a radius of 5, that the amount of stuff like area in between, like in that ring, that
It
little
grew,
ring
increased.
is going to be the next time when it's 5 to 6, it's a little bit bigger because the radius is just a little bit bigger. And then in 6 to 7, it's going to be a little bit bigger than that, but not much. But it's over the count of like.
So what I'm picturing is an archery target with concentric circles.
Yeah.
And each ring is the same width,
Yeah.
right?
Yeah.
But the area of each ring is more than the one.
Yeah, it's like if you
Smaller.
strain them out, it just keeps getting longer and longer.
Yeah, okay, so you roll the
That's-
circles out to be rectangles. I got you. Is that what you were thinking?
Yeah, that's
That?
what I was.
I like that too.
you make
And
them
actually
straight.
that's an old Greek method for approximation, approximating area of circles. But okay, so I hope I got your intuitive thinking about this straightened out a little bit. The bigger the circle, the faster the area grows, even if the rates of the radius growing are the same. Did you get big hands? I know you're the one reference. Nobody caught one. Olivia caught that. That was it. Thanks a lot.
Wait, was that what you talked about?
I don't remember if that's an appropriate song or not. I'm sure you've heard worse. 14. Let A be the area of a circle with radius r. Area pi r squared. If drdt is a constant, drdt is a constant c. It is dAdt is equal to a constant. It's kind of funny, but we do use k as a constant also. Is that true? Is dAdt a constant? Explain. So I summarized the question in math speak, right? So I know the area of a circle. I know the radius is changing at a constant rate. Is the area changing at a constant rate also? That's what this is asking. So we need to have a dAdt and a drdt. We take the derivative with respect to time. dAdt equals 2 pi r drdt. And then if we plug in c for drdt equals 2 pi r 2 c pi r. Can I do that? Slide that constant in there.
You just put 2 pi RC.
Yeah, but r is still a variable. So I kind of want to say this is the coefficient of the radius. If I put c at the end, it wouldn't be quite as clean.
You just have to plug it in.
So this whole thing is a constant. Is dAdt a constant? Why not?
Because there's an R changes.
R changes. The change in area relies on the radius. Wait, we just said that, didn't we? Didn't we just say that?
Last problem.
Yeah, that's what this whole thing is. This one's just like proving.
Yes, yeah, it is. It's pushing this further into your filing cabinet in your brain. Okay, so the area changes, but that change relies on the size of the radius. It does rely on the change of the radius, but if that is a constant, if it stays the same number, then the radius is still affecting the change in area. The bigger the radius, the bigger the change in area. So 15. What's the formula you use for 15? Oh, we're on B for 15. Oh, it gave it to us. A equals 1/2. Yeah, we did. S squared sine theta.
Wait, hang on.
Didn't we?
How do you skip the?
Yeah, no, we did. It depends on if you wrote it down.
It's right here.
If you didn't write it down.
Yeah. So we started with areas 1/2 BH. I renamed B. Something. I changed the spelling of all this stuff. Oh, there it is. H and B. 1/2 BH. Simplify. Trig substitution. And we got there. Okay. So 15 says if theta is increasing at a rate. Okay. If theta is increasing at a rate, d theta dt. Okay, you got to get used to that. The words increasing and decreasing. If it's increasing, that means we've got a positive value of 1/2 radian per minute. 1/2, and I do write the units here, but I don't always keep them around for very long. Find the rates of change of the area. So find the ADT. When theta, when there's two of them, theta equals pi/6 and theta equals pi/3. So that's part A and part B. Okay. Okay. I think we're ready. We need to take the derivative of this, but I can see I've got a coefficient and I've got a product. I've got a coefficient and a product, so you have to recognize those things happening. Product rule, dAdt equals 1/2 times first d last plus last, D first. DS dt. I forgot something somewhere. Where was it?
I thought you added something.
I'll
So
go
you
back.
have a half, and I thought you said.
I'm gonna go back and check, but where did I mess up? Yeah, where's it go? It is, yep. So I'll go back through, look, d/ADT,
Where's it go?
I'm keeping the coefficient out.
Make your mind up.
Listen, shh. First, D last. So it's product rule, okay? First, D last. First is S squared. The derivative of sine theta is cosine theta, but with respect to T, it's cosine theta, D theta, dt. And then, oh no. Plus, there we go. That worked really well, actually. Plus, last, so last is sine. D first, the derivative of S squared is 2S ds dt.
Could we say the derivative of x squared is 0 because it says x is a constant? Because at the problem 15 says the two sides of constant. I like that.
Oh man,
He's right.
he is right.
Aaron's right.
No, that was a good catch. No,
I'm
I
pretty
like
sure he's
that.
right. So the answer is- Pretty sure he only speaks when he knows the answer. He's really into stuff like the rest of the time.
That is fair. Half the
What?
time I'm speaking, I don't know what I'm saying.
I'm just sitting here somewhat paying attention and don't.
This might be a stupid question,
No.
but is S squared a constant just because S is a constant?
That's kind of what I was thinking about along those lines. The answer is obviously yes, but I worked ahead, and if you say S is well, if you say S is a constant, then it does change the derivative of this to be not product rule. But I don't think if, oh man.
Ah, hard question.
Well, let's see what happens here. Let's see what happens if we go on. Does it mess things up? Or do we just have to pick a number for S and say that's what it is?
I think 0.
Let's see where it goes. But I like Aaron's line of thought. It shouldn't matter. The math is consistent.
Just to wait.
Yeah.
We can't see.
d/ADT equals 1/2 times S squared, which is a constant, times cosine of theta, cosine of pi over 6.
Okay,
We should know this.
You should.
yeah, I should. That's what we can do.
Is that one, 3, root 3?
Yeah.
Yeah. Yeah, if we both got it, it's got it.
We all slam our brain cells together.
We have a collective IQ of
How's that?
27.
Does that help?
Us three were like half an
You can't see that. Neil, where are you at? I just drew an awesome picture and you can't even see it.
Yeah, I know.
How's that?
So bad.
Is that enough?
Wait, hang on.
Is that enough for you?
Yes.
Okay.
Wait, what?
Am I not
Is
enough
that not
for you?
switched?
What?
Because isn't 5 over 6 smaller than pi over 3? So shouldn't it be down here?
That's a pi over 8.
Oh, is it pi over 8?
That's
Wait,
what it looks like.
Wait. Oh, you're right.
I could be wrong, but I.
Wait, is it supposed to be?
So-
Pretty sure I know how to buy.
So I asked myself the same question.
Oh, he just.
I asked myself the same question and I came up with the wrong answer. Pi over 3 is up here. It's the 60 degree. And then pi over 6 is down here. It's the 30 degree. So cosine is x, right? Cosine is X, so it is,
It starts at 1, so it goes to 3. So it's 3. Right?
What are you talking
Because,
about?
because the, at,
Mean square root.
at whatever, like 0, it's 1.
Yeah, it's square.
Yeah, it's 0, so, or it's 1, at 0, it's 1, so 1, it has to go down now.
so it goes down to root 3 over
It has to go
2.
down to root 3 over 2, and then it goes to root 2, or root
Yeah,
2
you
over
did-
2, and then 1 over 2.
It got confusing because you didn't say what you meant to say,
You said
and you didn't catch it. It's okay though. Root 3 over 2. So where I see that,
It's
Oh.
16.
so pi over 6. So at pi over 6, I've got root 3 over 2 is my x value. And okay, so we'll keep going. Root 3 over 2. D theta dt is 1/2 plus sine of theta. Sine of pi over 6 is the y value. 1/2. And 2s ds dt. Aaron,
That'd just be 0, right?
0.
And then so just. Yeah, it's all 0. I'm gonna exit out.
Okay. Yeah, so since s is a constant, it follows that ds dt is 0. How do we know s is a constant? You read the words in the problem. It says 2 sides of constant equal length s.
That's why I have a problem.
So now this thing simplifies to b, the ADT equals root 3 over 8, root 3 over 8 s squared, right here, 2, 4, 8.
Wait a second, what about the half?
It's there. 1, 2 times 2 times 2.
For some reason, my brain wanted to multiply the s.
Okay. So this is at pi equals 6. So this is really part, well, I can call that part A. Part B, at pi over 3, the ADT is,
Oh, I ran out of something.
okay, you do it. Give me an answer.
Yeah, guys.
Give it an answer.
I'll be back.
I'm mad now.
Okay, I remember pi 6, but I don't remember pi 3. That's what I thought.
Okay, I got an answer.
2 over 3.
Wow.
Aren't you just so smart?
Probably wrong.
He's so
Pete,
smart.
It's s squared over 8.
Oh my God.
You're
I
so
would
long
err.
over 8.
I was actually gonna do that problem, now I'm not gonna do it.
Shut up, I'd rather have the answer.
The second one, which is high, is like with the high.
You can still do it, Caleb.
No, I don't want to say I do the answer.
S squared over 8. There we go. Work smarter, not harder.
I know.
I'm gonna have a job in the future. I'm just gonna be calling
Maybe
you.
you'll say something.
Aaron. Hey, Aaron.
I know you're busy at NASA and stuff, but I need help.
You're just getting rid of the radical. How do you start it? It's just like a
Where's the on button?
He disappeared.
Record player.
What'd you get?
I don't know, Aaron screamed out the
That's
answer.
squared
so I
right.
stopped.
That's square right.
I moved slow.
No.
Caleb's lying.
Will? Did you just say that?
Oh, I said it?
What'd you say?
That's square root.
Did you say that all by yourself?
I mean, it's self-explanatory. I mean, you just give it a radical 3/2 plus your.
That's all I did.
Yeah, that's all.
Good.
How do you get?
No, Will actually got the answer wrong.
I still understand. Oh, 'cause you have it.
It's the same thing.
So yeah, if we look here, we know that this is going to zero out over here. So it's just going to be 1/2 times s squared times cosine of pi over 3 is 1/2 times d theta dt is 1/2. So Will says it's obvious. You just change the root 3/2 to the 1/2 over here. That's all you got to do. When you do that, you get, I'm going to write it the same form, 1/8 s squared. So the area is changing slower as our triangle opens wider. The area is going slower as our, remember this is an isosceles triangle, SS theta. So it's opening at a rate, okay? Theta is increasing at a rate of 1/2. And what this is telling us is as theta opens, the area is changing slower. This, I like these because they make things like intuitive.
It makes me think.
Makes you think about things moving around. 16.
It makes me try to.
Oh, we didn't do C, did we? Sorry. Explain why the rate of change of the area of the triangle is not constant, even though d theta dt is constant.
Because radius.
It's the same thing with the circle.
Oh. Except for C.
It's like,
So.
Explain why the rate of change of the area is not constant, even though d theta dt is constant. What changed? Theta. So just like the circle's area relies on the radius, the triangle's area relies on theta. So the theta is what drives dA dt. What's the explanation? dA dt relies on theta. Okay. 16. Oops. 16, the volume, radius of a sphere. So volume is 4/3 pi r cubed. I know I'm probably going to need dV/dt, so let's just do it. 4/3 pi r cubed. Cubed makes this a 4 pi r squared, dr dt. Might as well just knock it out. The radius is increasing at a rate of 3 inches per minute. So dr dt is increasing. The radius is increasing. So dr dt is +3. I wish they would do some decreasing. Inches per minute. Part A, find the rates of change of the volume. So dV dt equals question mark when at r equals 9 and r equals 36. Oh, this feels like the circle problem, doesn't it? And the triangle problem. Number 13 that we did. So does the change in radius of the sphere affect the change in volume? You have a guess? If the radius is bigger, is the volume going to change at a different speed, even though the radius is changing at the same speed?
Yes.
It's going to be different. Okay.
Still gonna be the same circle concept.
It is, yeah. We're just pulling the circle into 3D. So dv dt equals 4 pi r squared. So 4 pi r squared dr dt is 3. So what is this? 81 times 3 is 243. 243 times 4 is 972.
Yeah.
Check me on that.
Yeah.
I did with my
Thank
calculator.
you.
Just subtract 28 from
There you go.
What?
No, because you.
That's pathetic.
250 times 4. 250 times 4 is 720 from 250 is 243. 243, 243, 7.
I didn't follow a word you just said, but it's just because it was way above my head. That's all.
I too will rattle off numbers. So you get it right.
Part B, dv dt equals 4 times pi times 36 squared times 3. Do that one, Will.
Yeah, Will.
Yeah, Will.
Do math. Do math. Do it fast. Do it fast. Will. Do the math, Will. Pick it up.
6 to the 5th
What's the
times
answer?
2. I know it's 6 to the 5th power times
I'm just
2.
gonna let you two duel it out.
Oh, that was so
I was just gonna keep. I was just gonna keep putting pressure on Will until he said the wrong answer.
Somebody do it. You get it?
Will.
What
What's
is
the
it?
answer, Will?
196 times 3 and then times.
What?
Oh, okay.
That's not an answer. What's the answer?
What did I say? 1,196.
1
5, 5, 5, 2, 5.
5 5 2.
That's a lot of
Yeah,
math.
4, 5. There's 3 5s. 5.
I think you could have got
I could have.
it. I think you could have got it.
Cubic inches per minute. Cubic inches per minute.
32 squared is 1,000.
So same idea as the circle. The radius changing does increase the rate that the volume changes.
Why is it?
Why? Because the change in volume relies on the radius. Okay, how far were we going?
We said 22.
22.
I don't know if we're gonna make it happen.
I am out of space.
We just need to quit going on.
A spherical, oh, I love the spherical balloon problems. A spherical balloon.
Wait, do they have square balloons?
Wait, no, hold on.
A square doesn't hold air.
But spherical balloons suggest the
Is that a
existence of
challenge?
non-spherical balloons.
Yeah, I'll bet you $1 billion that you can't make a square hold air.
Where I'm searching it. Where's the square?
Give me a second. Someone find a cube.
I didn't say a cube, I said square.
Square balloon.
Yeah, square can hold air. Of course it's square.
Oh, they're cheating. They try to make it kind of round.
Yeah, you can't do that.
No, but I'm saying, he's saying it's because you can't do it because it's a 2D shape.
Air is 3-dimensional and square is
A
2-dimensional.
cubicle.
That's
Yeah.
why he
You
says,
can't.
he's trying to be smarter than everyone else.
So,
Well, it's.
He is.
all right, we're getting more into, I think this is the last one I'm gonna do,
No.
and then I'm not gonna ask you to do the others. I'm gonna give you something
That's
else.
the right answer.
So 17, I've got this spherical balloon. This is the first one where it's like an actual real life object. It's inflated. So if a spherical balloon is inflated, what is changing? Diameter, volume,
Everything.
radius, surface area. It's all changing and it's all getting bigger. Okay, so reading on, it's inflated with gas. at a rate of 800 cubic centimeters per minute. What is that rate, 800 cubic centimeters per minute? What's that applied to? Diameter, radius, volume, surface area,
Volume.
Area. Volume.
Volume.
dAdt,
Volume.
drdt?
VD.
Let me write it down so you can see it.
Volume is the only one that's key.
Oh, there you go.
800 cubic centimeters per minute.
Can't do air.
Ooh, so it's air pressure.
It is,
Close
well,
container of gas. APCalc.
so since it's cubic centimeters, yeah, it is going to be volume. So you can tell the rates by their units. What is this, the rate that's, what rate's changing? The rate of the volume. Then how fast, so that's asking about a speed also, how, or a rate. How fast is the radius? Stop right there, drdt. How fast is the radius of the balloon increasing at the instant, the radius is r equals 30 centimeters and 60 centimeters. So this is part A, this is part B. So now we've got a spherical balloon and it is being filled. I have to include the helium tank,
I just
right?
like the fact that there's
We're
a
running
face.
out of helium.
If you look hard
I
enough,
know.
there's a face and you're moving that, like,
There is.
If you look.
he's a little happy.
I'm not.
Look at him go.
Oh,
Oh, now he is.
no. No. That was not the right decision.
Angry balloon.
It's like in Super Mario, with that little chain balls.
Ugh, the chomp chomp.
If the
Chomps.
balloon has teeth, how is it not popping itself?
So since it's a sphere and we are talking about the change in volume, we need to talk about the volume first. So volume is 4/3 pi r cubed. We need to have this in terms of this thing changing, moving. So filling this up, take the derivative with respect to time. And we get 4 pi r squared dr dt, just like we did in 16. Same derivative. You start the same formula, you get the same derivative. Now it'll be plug and chug here. So 800 equals 4 pi r. 4 pi r is 30 for part A squared. So this is part A. Times dr, we don't know. We're solving for dr dt. What is that? 45
Big enough number, I don't wanna do it.
pi over 45.
It doesn't take a big number though to make me wanna do it.
So this 4 times 30 squared, that's 900 times 4. That's 3,600 pi, right?
Yeah.
So I'm going to divide both sides by 3,600 pi. And I get 1 over, wait, 2 ninths. Can I say that? 2 ninths, 2 over 9 pi. Did I do that right?
Yeah.
2 ninths is 0.2 repeating.
Yeah, you did.
Oh, but pi goes on bottom. And then units. The units would be centimeters per minute. That's pretty slow. 9 pi minutes is almost 30. So it's like 1 centimeter every 15 minutes with a radius of 30 centimeters. And then part B.
Maybe the leak is in his mouth.
Part B is the same formula, but we're going to change the R values. So 800 equals 4 pi times 60 squared dr dt. Is that 15,600? What's 60 squared? What's 3,600 times 4?
I got 14,400.
What?
I got 14,400.
Oh, okay. Yep.
Oh, I have to raise it now.
You know better than to write numbers that I write.
That's what I've been doing all day. Wait a second.
So divide that by
Are you sure this?
14,400 pi.
Oh, let me just, give me a second, I got it in my head.
What's the answer, Grant?
Is that 1 over 18 pi? Tell me that's right.
You actually ask Eric.
Thank you.
I never knew that. You might know right off the top of his head.
I don't- That's what I want.
Okay.
I wanted to feed me the answer.
Wait, which one of those is bigger?
The top one.
This one?
Yeah.
This one's bigger.
The tippity top.
They're smaller numbers.
So the radius is changing faster when the radius is smaller.
Because there's
When-
less space to fill, to make the radius, you know what I mean?
Yeah, we have to think backwards, right? Because now we have a constant volume coming in. Well, think about it. When you blow up a balloon, you're blowing up at a rate of 1 breath per second or whatever. As the balloon gets bigger, it feels like it's not filling up quite as much, right? So that's really what's happening there. Okay, I said that was the last one, and it is. So we're actually going to look at some AP problems.
No.
I was gonna ask.
We were forsaken.
I was gonna ask questions over 6 and 7.
6 and 7.
From the other.
Yeah, from the other.
Oh.
Yeah, I definitely think it's 6.
No, I definitely got confused and when I went back over my work, it was way wrong.
Yeah.
Man, this is.
We did some example problems the other day and then I looked at 6 and 6, 7, 8 and I was like, oh, those are all wrong. I don't even know what I was doing.
Yeah, I remember that.
Whatever I did do for 6, 7, and 8 is already bad.
How are you? How are you doing? Good.
I don't need to ignore you.
I thought it was. I got.
Oh my God, both of course at a 20%.
I probably have 25.
You did that math so good.
All right, so these are actual AP problems. And the year and the number are there also. So we'll hit a few of these together, but then I'm gonna let you, this is your homework assignment. Let's do,
One of the back ones.
let's see, railroad track.
I think I could just like define these.
Yeah, I know.
Exactly.
That's the one I want.
That's
That's
the
the
point.
point. Yes, exactly, that's the point.
I don't think he
Oh, so-
understands the concept of not being.
Okay, so we're supposed to do the back on pages, right? And then we run 3 problems.
I say we do like 5 and 5.
I get it now.
I say we do 2003, 5.
Actually,
2002, 5.
I think I'm just gonna draw some pictures with you on as many as, well, a few of them.
Let's do that. That's-
So 81, a railroad track and a road cross at right angles. So
That's basic.
Nobody never got nowhere but golf.
So you never heard of it.
That is not a right angle, Mr. Wade, I hate to tell you.
Actually, I think it is.
now it is.
I don't know, it looks right to me.
Like there's a little skirt.
Now it is, now it is.
No one got
It
it.
wasn't. I got it.
Wait, what'd you say?
He said it looks right to me.
Look, it's been a long day. I want to be here. You don't want to be here. You gotta listen to my fun stuff.
An observer stands on the road
I think you're.
70 meters south of the cross. Oh, man.
I don't know. He's on the right track.
Wow.
Too bad, I'm gonna kill you.
There we go.
Might be true.
You can't see it.
Well, there, Kevin, do I have to?
Sorry, I had to do that.
Only
Um, An observer stands on the road 70 meters south of the crossing. So here's my observer, giant observer, I guess.
Big boy.
70. And watches an eastbound train. Are you kidding me?
And eastbound.
An eastbound train traveling at 60 meters per second. At how many meters per second is the train moving away from the observer? 4 sec. Okay, good. All right. I was afraid I messed up my directions again.
That is quite an interesting train.
Don't judge my train.
Yeah, Caleb, don't judge
You know, mine looks cool. Mine's cool. Mine's a box.
Ooh, whoa. Fancy.
It's pretty good. Pretty good.
It's cooler than sand.
Choo-choo train. Okay, back to an observer stands on the road 70 meters south of the crossing and watches an eastbound train traveling at 60 meters per second. So it's traveling at 60 meters per second. How many meters per second is the train moving away from the observer 4 seconds after it passes through the intersection? So moving away from the observer means this distance right here is changing. What do you want to call this distance right here? X?
Riley's answer's not there.
H?
Yeah, H.
Y? Okay, all right. Everybody agreed on H. I'll go H.
I say C.
Okay, now what do we want to call this distance? Because it's changing too.
Oh, so because it's great.
Well, it is a right angle, but we don't know that it's an isosceles
Oh, yeah.
triangle
I thought I don't even know why.
because your medicine wore off.
It was legal.
You said it first. What do you want to call this? I like calling them ABC.
Nah,
I
I
was
think
thinking
it's
ABC.
I'm calling this distance right here A. Okay. So now I've got this triangle. This distance is A. And the train is moving along path A at 60 meters per second. That means A is increasing, right? And it's increasing at a rate of 60 meters per second. At how many meters per second is the train moving away from the observer? Well, away from the observer, that's H. So it's asking at what rate is H changing 4 seconds after it passes through the intersection at T equals 4. What? So I need two formulas for this.
Oh.
Well, you can guess.
Could you just write A, or could you just write A in terms of T? So that way you can just like.
Okay, how much is A? So this T equals 4 means A equals 60 T, yeah. So let me take it down to the bottom here. Bottom, that sounds bad. It's not the bottom, it's, let me take it down to layman's terms. How about that?
No, don't worry. we
So,
already saw it.
Feel like
the-
a dog.
The distance A, this distance A
You need not worry, I'm-
increased by 60 meters every second. So after 1,000, 2, 1,000, 3, 1,000, 4, 1,000, it went 60, 60, 60, 60. Does that make sense?
That's a constant.
So that's 4 times 60, which is 240. Okay,
That's impressive. That's what I said.
I think that's all I'm gonna do for that one. Sorry, it went sideways. Let's look at the next one.
Wait, hang on.
No.
You're gonna have to look at it like that.
Be faster, buddy.
Yeah, catch up.
So this one says, the radius of a circle is decreasing at a constant rate of 0.1. The radius is decreasing, so dr dt equals negative. Okay? Right away, you would write that in 0.1, negative 0.1 centimeters per second. In terms of the circumference C, what's the formula for circumference?
That's a great one.
2 pi r, thank you. What is the rate of change of the area, dA dt, of the circle in square centimeters per second? In terms of the circumference C, what's dA dt? Don't I need A also?
Yeah, well, we know.
If I need dA dt, then I need A.
This is the AP exam, you're not supposed to know the answer.
Okay, I'm just gonna, oh, look. Okay, so it took me a minute. Not really, but I remember back to where you're sitting. It took me a minute to remember what this means in terms of the circumference C. But then when I saw dA dt was what we're solving for, and the answers all looked like this, I knew that I'm gonna have to change this somehow to have a C in it. And it's actually easier than you think. So
Do I have to change it?
if you trust the process, it's showing you that we need dA dt. So let's just take the derivative of area and see what happens. dA dt equals 2 pi r dr dt. This is this. So just substitution. So dA dt equals C dr dt. And I'm moving on. No, I didn't.
We know DRD.
78. The radius of a circle is increasing.
He's like, no, it doesn't exist.
The radius is increasing. What's the rate of increase in the area? Okay, that's all I'm doing for that one. I overdid the last one. I'll just do that one.
You did it perfect.
This is your homework.
It's just a circle with an arc.
I'm gonna skip to 5.
Yes.
5. 2007 FRQ 5.
2007.
Wait, we skipped 88?
No, you just weren't paying attention. The volume of a spherical hot air balloon expands. Oh, spherical hot air balloon. It's super important that it's a hot air balloon, though.
If that way you can make it, you can't make it a change.
With the one in the middle.
Make it an ice cream cone.
Oh, that is true. Ice cream cone, there you go. That's pretty much ice cream.
Expands as the air inside the balloon is heated. The radius of the balloon in feet is modeled by a twice differentiable function r of time t, where t is measured in minutes. So all that's saying is that r is going to function normally for calculus to work on it, basically is what it's saying. For the times between 0 and 12, so from 0 to 12 minutes, the graph of r is concave down. What the heck? The graph of r is concave down. The table above gives selected values of the rate of change, r prime of t, of the radius of the balloon over the time interval. The radius of the balloon is 30 feet when t equals 5. Note the volume of a sphere is given by this. Find the rate of change of the volume of a balloon with respect to time when t equals 5. A. Oh, A was, so this was pulled straight from the exam. A was not a related rates question. A was something else. I don't know what it was.
So we couldn't do
I don't know. I don't know what it was.
it. I mean, I'm not complaining you didn't give it to what it is.
So find the rate of change of volume. We can at least do that without understanding everything. We can at least do that. dv dt. You should probably have this memorized by now. 4 pi r squared. This is the third time today. dr dt. When t equals 5. So at t equals 5, what's r prime? I could say r prime of 5. T equals 5, r prime is 2. Right?
Brain
Yeah.
Just go with
is in brutal.
it.
So basic.
Class.
I feel bad.
So basic.
I feel nothing but.
You did start that recording.
All right, moving on.
You did start that recording,
No, he just forgot. Now everybody else is screwed.
I think it's still recording.
Oh, yeah.
Yep, it's still recording.
Sorry for those of you who left, but you get nothing. So
We don't even have a home.
You did basketball.
Number 5, a coffee pot has the shape of a cylinder. Show that dHdt equals negative root h over 5.
Bus 26 will replace bus 31 today.
Yeah, it will.
So I'm going to start here because I don't know where else to start and I didn't read it.
you're right. That seems like a great place to start.
Oh my gosh, I can't remember this one.
dv dt equals pi times, oh, that's product rule, isn't it? First, oh, sorry. First, d last, dHdt plus last, d first. I think that's a good start. You want to end up solving this for dHdt, but along the way, you have to read. Okay, finish the rest for Friday? Friday.
Yeah, Friday.
Yeah.
Friday.
I got you guys.
take pictures and submit that homework.
I'm about to write the assignment for that.
I mean,
All right, reader. If you didn't download that file, I'm going to post it on the agenda for today also.
I printed it off. I'm good.